In this recording, we're going to look at an application of trig graphs, specifically a tide example. As you know, tides go in and out cyclically, so they're an excellent choice for something that could be modeled by a sinusoid, a sine or a cosine graphs. So I'd like you to get a piece of graph paper, give yourself this heading, and then write down the relevant information in this question, specifically that we have a tide example. Write down the equation. Note what t is. T is the number of hours past noon. Y is the height of the tide. And we're interested in finding out this information graphically. For how many hours between t equals 0, t equals 12, is the tide at least 5 feet? Okay, so play the recording once you've gotten that written down. Okay, now I'd like you to write down the details of the graph. Okay, using this equation here, I want you to write down what you think the amplitude is, the period is, and the vertical shift. Now, don't be thrown off if you get a period that is an integer. You would expect that because we're talking about a period in hours. Okay, then you can play the recording once you have written down what you think those are. Okay, so hopefully you wrote down the amplitude is 2, that's our A value, the height of the wave. The period's always 2 pi over b, so 2 pi over 6. So we've got a complex fraction, multiply top and bottom by 6. It gives us 12 pi over pi, 12 hours. And if you've ever been to the seashore, you know that that's not a bad approximation. It's not exactly 12 hours, but it's not too far from it. In other words, you're going to see a high tide at 4 in the afternoon, then you're going to see another high tide close to 4 in the next morning. Okay, every 12 hours it gets back to a high tide, more or less. It's not exactly 12. And finally, the vertical shift is 4 units up. Next thing I'd like you to do is set up your axes. Okay, we don't need 4 quadrants. We're only dealing with positive values of time and positive values for height, so you only need a first quadrant. I want you to think about how high you want your axes to be for the height direction and how wide your axes should be in the time direction, and label it appropriately, and then play the recording when you're ready to look at my axes. Don't cheat. Don't play it yet. You haven't written down your axes yet. Play it when you've written down yours. Alright, hopefully your axes look something like this. We're going between 0 and 12 hours. That was the domain that was provided. And then write down what those hours stand for. They're the hours past noon, because that's what it said t was. Now you've got your y-axis labeled between 0 and I went up to 8. You might say, well, I don't know how far I'm supposed to go. Well, I guess the way to think about it is the vertical shift is 4, so that means our nodal line is going to be right here in the middle. Let's go ahead and put that in right now. The nodal line is right there at 4 feet. And we have an amplitude of 2, so you know that that means it's going to go up 2 above and 2 below. So I think this is appropriate scale. Alright, next, now that we've got that nodal line sketched in there, we're going to need to plot the 5 points that make up the cosine wave. Okay, think about where cosine starts. It's a positive cosine graph, has an amplitude of 2. Think about the period. The period is 12 hours. Should complete a full cycle within 12 hours. Okay, and you know that we always divide up a full cycle into 4 equal chunks. So divide out 12 into 4 equal chunks of 3 hours. So every 3 hours you should have a point plotted. I should plot those points. Play the recording when you've done so. Okay, so hopefully you've got these 5 points plotted. At 0, we know it's 2 above the nodal line or the midline, because that's what cosine does. It starts up at the maximum. And it ends after 12 hours, the same place it started. And every 3 hours we get one of those 5 points in the 5-point pattern. So it's a maximum, a 0, a minimum, a maximum, and a maximum again. Let's make a smooth curve. Now we've got the graph plotted between t equals 0, t equals 12. You've done all the hard part. I want you to go back, read the question for how many hours between t equals 0, t equals 12 is the tide at least 5 feet. I want you to shade in with your pencil the portion of the graph that goes above 5 feet. Then play the recording. Hopefully you shaded in this little part. That's only part of the graph for which the tide is above 5 feet. Now you just have to look and see, okay, how many hours was that? Well, it looked like it went 2 hours and then another 2 hours. So altogether, what we can say is, for 4 hours, the tide is at least 5 feet. Thanks for watching.